Now, in continuation with the discussion on virtual memory, the next topic we will be seeing is demand paging. This again, we looked at it when we were talking about backing store, swap in, swap out. I think we discussed swapping with paging as a separate topic. So that is exactly what this is. The formal name or terminology is demand paging. So instead of loading the entire process from your virtual memory to your RAM, you load pages of the process. You divide a process into subsections or segments called pages, and then you load whichever page is required. So the idea is your process, every process has a bunch of data and instructions, right? And some processes could be huge. Now if you want to execute some segment of a particular process, if you are going to load the entire process from your virtual memory into the RAM only to execute one segment of it, that is a waste of your RAM space, right? So RAM space as well as computational resources. Bringing it from your virtual memory to RAM, then from RAM to backing store, backing store to RAM to virtual memory. A lot of swapping for no reason, especially if there are segments which are not going to be used at all. So what we do is you take a process, you divide that into pages. Whichever page or whichever segment of a process you want to work on, that alone you will load from your virtual memory into the RAM. This means a page that is not going to be used will not be demanded, therefore it will not be loaded onto the RAM. This means your RAM space is being saved. So that's a very simple, straightforward concept. That's all there is to demand paging.